Today's lesson is 7-7, and we're going to be working in your classroom packet. So as I go through problems 1, 2, and 7, please follow along and write them down. Today's lesson meets our learning target by using rates and ratios, quantitative reasoning, and using models of all different kinds. Today you have a choice. In the directions it says that you could use tables, factor puzzles, cross multiplication, and tape diagrams. You get to choose what you'd like to use today based on the problem and how you want to solve it. We're still looking at proportions, so we're going to read through each of these problems and try to problem solve through and find the missing quantity. So let's take a look at our first one. In a lab, chemical 1 and chemical 2 are mixed in a ratio of 4:5. How much of chemical 1 is needed to mix with 35 liters of chemical 2? So we're trying to find out chemical 1, but we know that there's a total amount of chemical 2 of 35 liters. So for me, I kind of like the tape diagram for this one. So I'm going to go ahead and I'm going to write C1 for chemical 1, C2 for chemical 2, and I'm going to draw out my ratio. So I've got, it says 4:5, so I've got my 4 chemical 1, and then my chemical 2 says 5. I'm going to try to keep them all about the same size, okay? And then it goes on to tell me that I have 35 liters of chemical 2. So I know I'm going to be using 35 liters of chemical 2. Well, we learned when using a tape diagram that if I know that the total is 35, I can take its parts and divide 35 by its parts. So there's 1, 2, 3, 4, 5 parts. And I know that 35 divided by 5 is 7, meaning that each part in chemical 1 and chemical 2 is going to be worth 7. So now, going back to the question, how much of chemical 1 is needed? Well, now that I know each of its parts, I can take 7 times each of its parts, which are 4. 7 times 4 is 28 liters. So my answer to number 1 would be 28 liters. Okay, let's move on to question 2. In a lab, chemical 1 and chemical 2 are mixed in a ratio of 4:5. How much of each chemical is needed to make 35 liters of the mixture? So now it's not just chemical 2 that has the mixture, it is the whole entire mixture is 35. So this is going to be a little trickier. I still am going to try to use the tape diagram. Chemical 1, chemical 2, chemical 1, the ratio is still the same, so it's going to be 4:5. Chemical 1 being 4, chemical 2 being 5. Okay, but now it's saying the total mixture is going to be 35 liters. So just like I did before, I'm going to take the parts of the total mixture, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm going to divide 35 by 9. Now I don't know what that is yet, but I know that each part, once I solved that, would be the answer. Okay, so now going back to the question, how much of each chemical? So they actually want me to find the total of chemical 1 and the total of chemical 2. So I'm going to take, there's 1, 2, 3, 4 parts for chemical 1. So I would take 35/9 times 4. So this is my basic multiplication. I'm going to put the 1 underneath. I don't see any way to simplify, so I'm going to go ahead and multiply. I know that 35 times 4 is 140, and I know 9 times 1 is 9. So then I'm going to actually find, take 140 and divide it by 9, and I should get 15 times. 9 fits into 140 15 times, and there's going to be 5/9 left. Now that's for chemical 1. So chemical 1 should have 15 5/9 liters needed for this right here. And now I'm going to do chemical 2. which is going to be 1, 2, 3, 4, 5. So it's 35 ninths times 5. Okay, so I look to simplify. There's nothing I can do. So I can go ahead and I'm going to get 35 times 5 is going to be 175. Once again, 9 goes into 1 9 times. If you're not quite sure how I got the 15, I can say, okay, 175 divided by 9, and I'm going to actually just do the division to find out how many sets of 9. 9 doesn't fit into 1. 9 fits into 17 one time, and that's 9. Okay, 17 minus 9 is 8. Bring down the 5. 9 fits into 85 9 times, and that's 81. And then I'm left with that 4. So I'm going to put it up here as that 4 ninths, and that's where I got the 5 ninths up here. So for chemical 2, I know I'm going to need 19 and 4 ninths liters. And that's it for problem number 2. Let's look at one last problem. It's on the back, and it's number 7. Okay, this is continued practice. And let's see if I continue to use a tape diagram. This one says at a factory, each assembly line produces 100 cans every 3 minutes. So we kind of already have our ratio there. 100 cans, the C is for cans, per 3 minutes. So there's our ratio. If 2 assembly lines are working, how many cans will they produce in 15 minutes? So kind of like I set up before, I'm going to try to find out how many cans are set up, but now I want to know in 15 minutes. And that's why I put the little letters above, is it helps me to know where do I put the 15, either here or here. So in this case, I don't think I'm going to use a tape diagram. I could, but in this case, I think I'm just going to use cross multiplication. So I'm going to write this as a fraction. 100 over 3 should equal x over 15. Using cross multiplication, I'm going to do 100 times 15, and that should equal 3x. Then I'm going to take the 3 and the x, and I'm going to isolate the x by dividing and doing the reverse operation. Then I'm going to divide this by 3. 100 times 15 is actually going to be, I can do 1 times 15 and then add on 2 zeros, divided by 3. Then I'm going to take, I know 3 goes into 15 5 times, and I can just put my zeros back on. Now, if I stopped there, my answer would be wrong, because I just did this calculation based on one assembly line. How many? 100 cans every 3 minutes. I need 2 assembly lines, so I need to double this number. So 500 doubled is 1,000 cans per minute. And that would be the end. So today's practice is going to be to continue to use either the tape diagram, the cross multiplication, the ratio table, or the factor puzzle to solve proportion problems. Good luck.